Speaking about microalgae cultivation technologies.
Good afternoon, everyone. First of all, thank you very much to the organization for the kind invitation for us to be here and to present a little bit of our work, and for me to give you some ideas, some concepts on microalgae cultivation technologies, which is something that I've been working with since 14 years now. Going right into the presentation. So first of all, let me give you some highlights about ourselves at A4F. So we are a company that essentially is specialized in the DBOT process. So we design, build, operate, and transfer commercial scale microalgae and microalgae cultivation units. So this means that if you want to become an algae farmer, you can come to us and we will assemble the cultivation unit for you and even train your team how to run it. This is our core business, and besides that, we supply also technical services, technology and consultancy in all things related to algae, also in the scope of fermentation and biorefinery of algae biomass as well. So we have a booth here, so if you want to come and visit us, just exit this hall and turn left, and we'll be right there looking forward for some interesting discussions. Okay, so our company was founded in 2008, and we are about 50 people. We are dedicated not only to R&D projects, which is how we develop our technology in several areas, and then we also have our commercial part of the company, which is supplying technology and commercial scale production units. So just for you to have a look at our portfolio, our track record in R&D projects that are developed together with other companies, with universities, with research institutes. Some of these projects are funded by the European Commission and others by national governments. So the range of topics is quite high, from the technology for cultivation to different products to tools for cultivation itself, preventing contaminations, you name it. We have a long track record in this. And for microalgae species that we have already cultivated in the past at pilot and industrial scale, more than 20 species that we have worked with so far. So we are well versed in different kinds of applications, of markets, and also of algae species. For seaweeds, which we also work on, our track record is not so extensive because we started working on this for about 5 years now, but we already have some experience at pilot and industrial scale cultivation for these 4 species. So the resources that we used to put at the availability of our clients are our innovation laboratory in Lisbon, and also a pilot unit that's about 10 cubic meters in capacity with different kinds of cultivation technologies, and this is how we develop standard operating procedures or test what's the best technology for the cultivation of a particular species. So a lot of different activities are done here, also contract research for different customers. And we work with multiple technologies. I'll go into this a little bit more in the next slides. But we work both with open and closed cultivation systems. Depending on the project, on the location, on the purpose, we select what the best combination of technologies is for each case. So all of these resources that we have are used for our core business, which is to generate algae farmers around the world. So we have some industrial projects in our portfolio. This is the first one. It was developed in Portugal with a cement company. It's the Algae farm. The company is all microalgae. So we were associated with this project until 2015, when the client took over. It was completely autonomous, and until today, this unit is still running and producing valuable biomass. In this project, we developed industrial scale cascade raceway technology, so open systems, completely different from the previous one, which was closed tubular photobioreactors. So already this technology has been used on industrial scale in another project. And this is our first seaweed farming project that we developed for a customer in Portugal, in the north of Portugal, and this is currently in implementation stage. And the last one that I want to show you is the Algatech Eco Business Park. This is the largest microalgae production facility in Europe. It's 14 hectares in size, and it is located just adjacent to a chemical industry, a former site of Solvay, Belgian multinational company, and working in synergy, integrated with different streams going from one side to the other, taking what used to be wastes now as raw materials for cultivation of algae. This is a multi-technology site. It has both closed and open systems growing the algae. And this is a very important project for us because it represents one of the things that we have targeted since the beginning of our company, which is to use algae production as a tool for circular economy and for decarbonization. And this is exactly an example of such a project. So, as you know, microalgae are capable of taking CO2, also nitrogen and phosphorus from effluents and using them as their raw materials for growth. So this makes it possible to have this integration with other economic activities and to have a cost reduction on algae production and simultaneously a good environmental impact for the traditional economic activities. So it's a win-win situation for sure. And this is just this project, the Algatech Eco Business Park. On the left side here, the algae production, and on the right side, the industrial perimeter where sodium chlorate and hydrogen peroxide is produced. And you can see that water, salt, CO2, nitrate, these are all flows that exist that travel from one direction to the other, thus generating this symbiosis, this circular economy approach for the cultivation of algae. And this example can be replicated also in other locations and with other economic sectors. So we are already accustomed since 15 years ago of doing this. And it's for us possible to identify for different economic sectors replacement of raw materials currently used, also replacement of end products that your industries might have, and that can be perhaps replaced by more sustainable sources by using algae biomass. And on the other hand, we can also do an assessment of existing industries and identify what are wastes today and can be valorized tomorrow as a way to promote the cultivation of algae biomass and valorizing that into different products, into different markets. Okay, so onwards to microalgae cultivation technologies. Now, the first thing I want to highlight is that cultivation systems are very important, but they alone, they do not make a production unit work. So it's as important to have all the auxiliary systems in place. That means water treatment, nutritive medium preparation, carbon delivery, the harvesting, the processing of the biomass, temperature control, effluent management, recycling of the culture medium, you name it. So all of these together actually make it possible to grow algae. And this slide is meant to show you just the complexity that is involved in deciding what is the best cultivation system to use for microalgae cultivation. A lot of people ask me this question, and I always give them an annoying answer about this, and the answer is it depends. Depends on the context, depends on the location, depends on the purpose of the unit. So here I try to show you a little bit the complexity that is behind this, the number of variables that are involved in this type of design, of selection of technologies. So you see here all the individual variables that affect the production of a particular species, and these are all governed by two main things. On the bottom, it's the purpose of the unit, and on the top, it's the geographic location, which influences the climate variables, but not only the climate variables. And in this case, so you can see also the connections between the variables. And we are just talking about autotrophic growth of algae, so based on CO2 and light. And this can be even more complicated because then there is also another type of growth, which is mixotrophic, which already involves an organic carbon substrate as well. So this makes it even more complicated. Then, of course, there is also heterotrophic growth, and this makes it a lot simpler. The diagram there, a lot of variables are now shaded, but it brings also a different kind of complexity for the carbon source that has to be used. which should be also of sustainable base, and it's quite tricky to get these parameters down for successful fermentation. So not only the variables that are governing the microalgae are important, but also in terms of the geographic location, also the context factors. Is there human resources available? How is the environmental impact measured? What kind of legislation is there that we have to follow? What's the water available for the cultivation? So all of these questions must come together for a successful design and for the selection of the best microalgae cultivation system. And this is a very good example of this. You can see here 4 different units that are producing, all of them, the same product, astaxanthin from Haematococcus pluvialis. And if you have a look at the pictures, you can see that the technologies used, they are very different. You can see that the first one is outdoor tubular photobioreactors in a place where there is a lot of sunshine in Israel. And the next case, we are talking about Iceland. So also horizontal tubular photobioreactors, but now using artificial light. There is little sunshine in Iceland, but there is available geothermal energy. So that justifies that choice of technology. But then have a look at Hawaii, where it's produced in open raceways. And then in the last case, produced in inside tanks containing light inside. But it's already a completely different system. And all of them producing the same thing. So makes my case about the selection of the technology, I guess. Okay, so there is production of algae in natural systems, in lakes that have abundance of algae, but they are not replicable. So we talk about only what can be deployed at a commercial scale in terms of systems. And they can be classified into these slightly misformatted types of systems. So we talk about 3 types. They're open systems, closed systems, and fermentation systems. And inside of those, we have some different options as well. I will go through them later on. Some optional features for all these systems that can be important: using artificial light, yes or no; using a cooling or a covering system, yes or no; and also high automation or more manual labor type of operation. These are just examples of parameters that need to be selected as well. For all these systems, one key thing is mixing, turbulence of the culture. That's how light is being distributed for all the cells inside the culture. And so this mixing also means that there is electrical consumption needed for all these systems, and it may be a good idea to combine this with renewable energy production, for example. So let's go through the examples of the cultivation systems. So first one for open cultivation systems, circular ponds, which is, you can see some of the pictures here. It's available at a decent scale, a large scale, but it's not very, there are few units around the world that are using this technology. And you can see, for example, this one on the opposite side, the conventional raceway technology. This is the most widely used technology around the world to produce algae, and available at very high, at 100 hectare scale type of units, or under 100 hectare scale. So there is also the cascade raceway technology, available also in industrial scale modules, but the largest scale so far does not go above 10 hectares, and there are not many units around the world, as this has been industrialized quite recently after a development from several decades ago in the Czech Republic. Now for closed cultivation systems, first one is the flat panel reactors. So these are available for several units around the globe, but they are not used at very large scale. So maximum scale is still under 1 hectare, so it's not easily scalable type of technology. The vertical tubular PBRs, or as well as bubble columns or airlifts, this is a very widely used technology for lab scale or for pilot scale. But for industrial scale, which is what I'm focusing on, there are not many units around the world using this technology. And the largest scale that can be found is still under 1 hectare in area. So this is also quite different from the horizontal tubular photobioreactor technology. In this case, it's very widely spread around the world, more than 100 units available everywhere, and the largest scale is between 10 and 100 hectare scale. So it's also a scalable type of technology. And the unilayer horizontal tubular photobioreactor, so these are just having one layer of tubes parallel to the ground, as opposed to the last ones which had several layers piled up vertically. These are also available in industrial modules, but they're also not available in a wide range of units around the world, but they are already existing in a large-scale facility between 1 and 10 hectares. And finally, the fermentation vessels that you can find here. So these are not so different from conventional fermentation technology for other microorganisms, but for algae-related fermentation, the numbers here say that there is already a unit that's between 1,000 and 10,000 cubic meters in capacity. Note that now we talk about volume and not area, because this is no longer so much dependent on area, because it does not resort to light. And this is already a widespread technology around the world with between 10 and 100 units around the globe fermenting algae. So what are the key messages that I would like you to have today? So you already know that algae are used for a wide variety of markets and applications, but they are also very important as a tool for decarbonization and circular economy approaches. The integration with other economic activities is something that can truly drive this sector for the next level. Second thing is that to decide what is the best cultivation technology to deploy, it needs to be taken into account the geographic location and the purpose of the unit. That's the best way to decide what is the best one. And it's also important to note that all the auxiliary systems are as important as the cultivation systems to have success in the venture. Then you saw that there are a lot of microalgae cultivation system technologies. I presented only the most representative ones because tens and hundreds of designs have been done over the last decades, and for sure some more developments may come in the future. But these are the ones that are available, deployable nowadays around the world. So they are divided into open, closed, and fermentation systems, and then subdivided into different categories. So how to decide, this is the advice that I leave with you. How to decide what's the best one is to rely on expert advice to make sure that the optimal performance of your unit is achieved and to avoid any mistakes that have been already done in the past. And with this, I conclude, so I will be available for questions after the session. Thank you very much for your attention.
Thank you indeed.